So we graphed the line y equals 2x plus 3. We started at 3. We went up 2 over 1, up 2 over 1. And we're talking reflection. What is a reflection again? Mirror image. Now, we're going to talk reflection. Now, the one weird thing with reflection is, does it matter where the mirror is? It matters. The weird thing about a reflection is it matters where the mirror is. Think about standing in a bathroom. If you're just standing here and the mirror's in front of me, what do I see? I see the front of my body, right? But if I'm standing this way and the mirror's over there, do I see the same thing? No, it's a different reflection, right? So it absolutely matters where the reflection is. So in this case, we're going to talk reflection over the y. Okay? We're going to talk reflection over the y-axis. So that means this is our mirror. Okay? Now, if that's our mirror, what's going to happen to every single point? So this point right here, where is this point going to move to? The other side of the mirror. So this point, instead of being 2, 1, 2, 3, 4, 5, 6, 7, 2, 7, it's now going to be over here at negative 2, 7, right? This point over here is 1, 2, 3, 4, 5 points away from the y-axis, so this point would go over here 5 points, right? Now, my question to you guys, this new line that I just drew, is this blue line the reflection of that red line? Yes, absolutely. All right. The question is, what's now the equation of that line? Y equals negative 2x plus 3. So, what we're doing today is we're going to move some lines around. And what I want to come up with is, if I say, here's my line, y equals 3/4 x plus 7, okay? The problems that I want to be able to do is I want to be able to say, if I take this line and reflect it over the y-axis, what is the new equation going to be? Okay? You think it's just going to be y equals negative 3/4 x plus 7? What do you think? So when we graphed it here, did we reciprocal it? Or did we just take the opposite of it? Opposite of it. So reflection across the reflection across the x, I can't talk. If you want to do reflection across the y-axis, what's the only thing you have to do? Opposite of what? The slope. That's it. If you want to do reflection across the y-axis, all you have to do is do the opposite of the slope. And that's it. No, we're going to do 3 types. There's 3 types of translations we're going to talk about. Okay? One is a reflection, which we already kind of talked about. What is another way that I could take a line? So I could take this line and I could reflect it. It's basically do this to it, right? So basically yeah, it's kind of messed. There it is. That's the one I wanted. So undo, undo. All right, so I could take this line and I could reflect it, right? So in this, moved over there, right? That's one type of translation. What's another type of translation? What is something else that I could do to this line? I could rotate it. Okay? I could rotate it. What does rotate mean? If I say rotate it, what am I going to do to this? I'm going to spin it around a circle, right? Now, what's changing when I rotate? The slope. The only thing that's changing when I do this is, let's say, here's my xy axis. Okay? There's my xy axis. When I take this line, oh, it's going to spin the whole thing now. Oh, I don't want to do that. Undo. Undo. Stop. No. Anyway. When I want to be able to, let's do this. Here we go. No, I got an idea. All right, I know this is how it's going to work. All right, here's my xy axis. We'll move this on top. Here we go. Move. Okay. There's my line, right? When I start spinning this and I rotate this, what is the only thing what's staying the same and what's changing? Is the y-intercept changing in this case? So the y-intercept is staying the same, right? The slope is doing what? The slope is changing, right? Now, here's my next question. With a rotation, counterclockwise versus clockwise. If I take, let's say my original line is red, okay? I have roughly the same line, right? What do you think my slope is approximately of these two lines? This could be y equals maybe 1/2. Maybe it's up 1 over 2. Plus, I don't know, that might be 3. Everybody agree that could be that line? This one, we'll say the same thing. Y equals 1/2 x plus 3. If I rotate it clockwise, meaning which way am I rotating? This way, right? So now my line looks something like this. What happened to my slope? Did my slope get bigger or smaller? My slope is getting smaller. Now, in this case, it almost went to 0, right? But it's getting smaller. When I go this way, my slope's getting smaller. If I go even farther, all it's going to do is go to negative, right? Now, it's going to keep getting smaller and smaller and smaller and smaller and smaller until it gets to vertical, which is undefined. And then, yes, it would jump back to positive if you keep going around. But generally speaking, if you rotate it clockwise, what happens to the slope? It gets smaller. If I rotate this counterclockwise, meaning this way, right? So now I might have a line that looks like this. What's happening specifically to my slope? It's getting bigger. The slope gets bigger. Make sense? So, if we have reflections, what's the only thing that has to happen with a reflection? So if this was like y equals 4/3 x minus 7, plus 7. This would be y equals negative 4/3 x plus 7. Reflection across the y is easy. All you do is change the slope opposite to negative, right? If I said I had two lines. Y equals 2x minus 3. And then I graphed y equals 6x minus 3. What's the only difference between these two? What happened to this line to become to this? The slope got bigger, right? And if the slope gets bigger, this would be what type of a translation? A rotation. Which way? Rotation, if it gets bigger, it's going to be counterclockwise, right? It really is that simple, right? Now there is one more type of translation. The easy way to describe it is I call it a slide. Okay? Now, with a slide, what's happening? Like, how do I take this line and slide it? Aren't I just doing this? Or this? Or this? Or this? Now, if I take and put this on a y-axis, what do you think the equation of that line might be? Y equals negative, I don't know, it might be like, we'll say it's down 2 over 3. What's the y-intercept approximately? Negative 5? All right, if I slide this, hopefully this lets me pick this back up. Yes. Which way you want me to slide it? Up, down, right, or left? You pick. Up. What do you think the new equation of that line is? Y equals? What stayed the same and what's changing? Is the slope changing? The slope didn't change at all, did it? What's now changing? The y-axis, the y-intercept is now maybe plus 4 or something like that. What's the only thing that really changed? The y-intercept. When you slide something, okay, it's actually called a translation. The formal term for a slide is this is called a translation. Okay? Now, you can translate up, you can go down, you can go left, you can go right. With a line, it's kind of weird because if I move it, let's say I move it down, okay? What's happening to my y-intercept? It went from 4 to negative 2. What happens to my y-intercept? If I go down, my y-intercept goes down, makes it smaller, right? What if I moved it left? What if I went left? What's the only thing that really changed? Wouldn't the y-intercept also just... So a down movement with a line and a left movement of a line ends up doing the same thing. Here's what I mean. If I say y equals 4/3 x plus 5, okay? And I say draw that. Okay? Let's say we have this line right here. It's going to be up 4 over 3. So maybe it'll look something like this. Okay? Would you agree that's approximately what that could be, right? Yes? All right. I'm going to copy that and paste it over here. Okay. Do you agree I have basically the same line drawn twice? Okay, I want to move this left. If I take and say move this line to the left, are you agreeing I'm moving it left? What's the new equation of this line? What could this be? y equals, is my slope the same? What's the y-intercept now, approximately? It's way up here somewhere. 8? So a left movement, what did it do? It made my y-intercept do what? Go up in this case, right? Wouldn't moving it up do the same thing? So a movement to the left and a movement up ends up kind of doing the same thing, doesn't it? And down and to the right will end up kind of doing the same thing. All right, everybody take a look at page 357. There's a few things that you kind of need to see. And this is kind of the general rules that you have to understand. Now, guys, we're going to take a quiz on this tomorrow. That's how hard I think this stuff is. No, I don't think this stuff is hard. That's why we're going to take a quiz on it tomorrow. I want to give you guys an opportunity to raise your grade tomorrow and get an easy quiz score. Wow, nice. No, I moved it to, right now it's scheduled for Tuesday. Because I did the re-quiz, that moved everything back a couple days. All right, everybody on page 357. On page 357, bottom of the page, a vertical translation. What's vertical mean? So basically we're moving up or down. Basically we're just sliding something up or moving it down. If you move it up, what happens to the equation? Instead of y equals 2/3 x minus 7, what would an up movement be? This equation would become what? 2/3 x plus 3, something like that. What's the only thing that's changing? The b value gets what? Bigger. A down movement, if I said y equals 2/3 x minus 7, and I said slide that down, what would be a new equation? Y equals 2/3 x minus 10. Right? When I move it down, the b value gets smaller. It really is that simple. Easy enough so far? Okay, turn the page. I want you to look at the red little box in the middle. A rotation. With a rotation, when you rotate something, is the b value changing? No. What changes with the b value? The slope. Okay? The slope is the only thing that changes. And I think you guys could even go one step further and say with a rotation, clockwise, the slope gets smaller generally. Counterclockwise, the slope gets bigger. Okay? They say when the m is changed with a rotation, it causes a rotation. The b doesn't change. Well, yeah, I think we can go even one step farther. And then if you look at the next page, 359, in that red box, a reflection. When you reflect across the y-axis, what's the only thing that has to happen? The slope becomes the opposite. If it was negative, it now becomes positive. If it was positive, it becomes... Guys, that's the whole section. Right there. Just those three things. There are three types of movements. There's a reflection, there's a rotation, and there's a translation. A translation, an easy way to remember it is a translation is a slide. That's it. So, everybody take a look at page 361. This is where your homework comes in. I want you to look at number 3. All you're going to do is describe what just happened. So if you have the parent function parent function is what it's called. The parent function is kind of where it starts. Okay? So the first one is f of x equals x, or basically y equals x. And then that became y equals x minus 4. What happened? A slide or a translation? Down. And that's, yeah, you don't even have to worry about that. Just down. Up or down in this case. Okay? Is that it? That's it. How about number 4? X became x plus 1. Translation up. How about number 7? X became 1/4 x. What changed in this case? The slope changed. If a slope changed, it became a what? Rotation. Now, what happened? The slope went from 1 to 1/4. Is that getting bigger or smaller? It's getting smaller. If it gets smaller, it's a clockwise rotation. So you would just say clockwise rotation. Look at number 8. 1/5 x plus 3 turned into x plus 3. Rotation.
But clockwise.
Did the slope get bigger or smaller? Got bigger, so it would be counterclockwise.
I want to take the test now.
That's it. That's all this is. Look at number...
Can I take the quiz now?
No. Look at number 11. Number 11, it wants us to reflect it across the y-axis. They give us y equals negative 1/5 x. Reflect that. Y equals positive 1/5 x. Look at number 12. Y equals 2x plus 4. It'd be y equals negative 2x plus 4. That's it. That's all this is. There's 3. What are the 3 types of what are the 3 types of movement? Reflection? Yeah, in slide is like the slang version. Slide is not the formal way. It's the translation is the formal word of it. I think it's easier to remember slide because we all know what a slide is. Translation's kind of a, if I say what is a translation, that's a little bit harder of a word. So it's hard to understand. When I think of translation, I think of transformer. Like it's just changing into something else, right? And it's, now, how is it changing? It's moving. And in all reality, think about a transformer. Think about the movie Transformers, or the toy of a transformer. What's happening to all the pieces? Aren't they sliding to a different area? Some of them do rotate, so that's a little weird, but yeah. Guys, that's all this stuff is. Is this stuff easy? Is it fair enough to say, let's take the quiz tomorrow because this stuff is just easy and we can get a good grade on the quiz? Okay. Yeah.